What's going on, people? It is your boy, Mr. Noland. How's it going, guys? Oh, what a nice, wonderful 3-day weekend. Now it's time to get back to the grind. Alright, guys, I'm going to be honest, these next 3 weeks, it's going to be going by extremely fast. You will have one test each week. Us math teachers decided instead of having one long test and you guys having to remember a whole lot, we broke it up into 3 different sections. Today we're going to go over prime factorization. Alright, so here we go. Use the following terms to fill in the blanks. We got prime, composite, prime factorization, composite number, and prime number. Number 1, a blank is a number that has exactly 2 factors, one in itself. So a number that can only be multiplied by 1 in itself is known as a prime number. Number 2, a blank is a number greater than 1 with more than 2 factors. That would be known as a composite number. Both numbers 1 and 0 are neither prime nor composite. Blank is when a composite number is written as a product of a prime number. This is known as prime factorization, which is what we're going to be doing today. Okay, I'm going to give you all just a few seconds to copy all that down. Again, these are just our typical vocabulary words. Now, some are like, wow, that's a lot. Guys, I'm going to be honest, this unit we have this week is extremely easy. It is very easy. Alright, I'm going to go and start moving on. Examples of prime numbers, where they have only 2 factors, one in itself. The first prime number you learned in elementary was 2. What multiplies to give you 2? Well, 1 times 2. Another prime number is 3. What multiplies to give you 3? 1 times 3. Now some are like, oh, there's a pattern. The next one is going to be 4. Guys, 4 is not a prime number. Think about it. What multiplies to give you 4? 1 times 4 and also 2 times 2. The next prime number you're going to see is 5. The only thing that multiplies to give it is 1 times 5. The next prime is 7. Again, it's just 1 times 7. Can anyone guess what the next one's going to be? If you said 9, you are wrong, because 9 is not prime. That's 1 times 9 and also 3 times 3. So 9 is not prime. The actual next prime number is going to be 11. That would be 1 times 11. And then you got 13. Now some of y'all might say 15 next, but again, you're still not right, because that's 1 times 15 and also 3 times 5. The next one is actually going to be 17. And the last one we're going to do today is 19. Are there more prime numbers than this? Absolutely, but we're just going to stop right there. So again, a prime number is a number that has only 2 factors. The number 1 and itself. That's it. Now, a composite number has more than 2 factors. For example, the number 4. 1 times 4 is 4. Also, 2 times 2 is 4. So there's more than 2 factors. 6, because you got 1 times 6, you also got 2 times 3. Again, more than 2 factors. Then we'll have 8, we have 9, we have 10, we also have 12, and so forth. But I'm not going to go through all those. Alright, when we're talking about prime factorization, we do something called a factor tree. Now, let's get to it. We need to make a factor tree. It is called that because it puts down roots. Alright, here's what we're talking about. What 2 numbers multiply to give you 40? And some of you are going to say 8 times 5. That's awesome. Some of you are going to say 10 times 4. That also works. Some of you are going to say 40 times 1. It does, but guys, I wouldn't use 40 times 1 because then you would do the factor tree on the 40 again. So there's more than one factor. I'm going to use what most of y'all are probably going to use. 10 times 4. Is 10 a prime number? No, so we got to break it down. What multiplies to give you 10? Well, 5 times 2. Is 5 a prime number? Well, let's see, prime numbers. Oh, there's 5. That's prime, so I'm going to circle it. That's as low as that number will go. 2, is 2 a prime number? Oh, yes it is. 2 is prime, so I'm going to circle it. That's as low as it goes. Is 4 a prime number? Oh no, it's over here. That's a composite number, so I got to break it down a little bit more. What multiplies to give you 4? Well, 2 times 2. Well, you already told me 2 is a prime number, so that's as low as it goes. Now, guys, what do you notice what I did? That made no sense. I didn't say it right, but every single one of my numbers is now a prime number. That's what you're trying to do, guys. You're trying to make your factors all prime numbers. Alright. So tips. Keep your prime numbers on the left and the composite on the right. Okay, well we did that. And then circle the prime numbers. Well, we did that. Okay. When all the numbers are prime, you are finished factoring. So guys, we are done factoring. But now there's 2 different ways of writing it. Now we will write our factors in factor form. When you write it in factor form, you go from smallest number to largest number. So we had a 2. We had a 2. We had a 2. And then we had a 5. There's your factor form. You're done. Now some are like, that doesn't give us 40. Well, think about it. What's 2 times 2? Well, that's 4. 4 times 2 is 8. 8 times 5 is 40. So actually that does work out. Now we're also going to write it in exponential form. You're going to start by writing your base number. In this case, my base number is 2. How many 2's did I have? 1, 2, 3. I had 3 of them. Times, what other base number did I have? Well, I had a 5. Now some of y'all say, let's put a 1 up here because you only had 1 of them. You can put a 1 up here if you want, but it's already assumed that there's a 1 because you already see 1 of them. So, guys, this is your factored form, straight from your factor tree. This is your exponential form. Seriously, you're done. Alright, now let's work backwards. We are given the prime factorization, now we must find the simplest form. We have 3 squared times 5 squared, and we broke it up to 3 times 3. I had 2 3's, and I had 2 5's. Well, guys, what is 3 times 3? Well, that's 9. What is 5 times 5? Well, that is 25. Now, if you've noticed something, all we've been doing here between is multiplying. So we need to multiply one more time. If I give you 9/4, how much money did I give you? Well, 4/4 is $1. 8/4 is $2. So that means 9/4 is $2.25. So 9 times 5 is $225. Well, guys, that's it. This is simplest form. Exponential form because I have an exponent. Factored form. It's coming from our factor tree. Now, I know some of you are still like, what? I don't get this. Guys, we've literally done like 2 examples. Calm down. Once you get a hang of it, you'll realize, wow, this is going to be an easy test. I should make 100. So let's go to the practice problems on the bottom. The first one says, what is the prime factorization of 36? So we're going to do a factor tree. What multiplies to give you 36? Most students will say 6 times 6, so I'm going to keep it like that. Well, is 6 a prime number? No. What multiplies to give you 6? Well, 2 times 3. Well, guys, 2 is a prime number. 3 is also a prime number. That's as low as they go. But look, I got another 6 over here. I have to do the factor tree on that one as well. Again, what multiplies to give you 6? 2 times 3. That's it. You're done. All I want you to do is factor it out. You're done. What is the prime factorization of 72? Actually, you know what? Hold on. I want to write this now in exponential form. So what's my lowest base number that you see here that we circled? It's 2. How many 2's did we have? Well, we had 2 of them. So that's 2 to the power of 2 times your other base number was 3. And how many 3's do we have? Well, we had 2 of them. That's exponential form again. You're done. All right, prime factorization of 72. Well, what multiplies to give you 72? 9 times 8. Again, are those the only factors of 72? No. You could use 12 times 6 if you wanted. Guys, at the end, you're going to get the same answer. Is 9 a prime number? No. What multiplies to give you 9? Well, 3 times 3. Well, 3 is a prime number, so that's done there. Again, 8 is not prime, so factor it out. Well, that would be 2 times 4. Well, look at that. 2 is a prime number, so I'm going to circle it. 4 is still not prime. You got to break it down. So that would be 2 times 2. Now we're all done. Let's put it in exponential form. What's your lowest base number? Well, it's 2. How many 2's did we have? 1, 2. We had 3 of them. Times, what's your other base number that we circled? It's 3. How many 3's did you have? 2. Done. Bada bing, bada boom. Now we're going backwards. It's an exponential form, and it wants us to simplify it into standard form. 3 squared means I have 2 3's. And then times 7. Well, guys, break it down. What is 3 times 3? Well, that's 9. And bring this down. What's 9 times 7? Well, that is 63. You're done. That is simplest form. Done. Again, it's an exponential form. It wants us to simplify it. 2 to the power of 3 means I have 3 2s. I also have 2 5s. Well, what's 2 times 2? Well, that's 4. What's 4 times 2? Well, that's 8. I'm going to do this side too. What's 5 times 5? Well, that's 25. Well, what's 8 times 25? There it is. It's 200. Done. Guys, that's literally all you're doing. On your test, you will have to do the factor tree. You will have to write it in factored form. You'll have to write it in exponential form. And then you'll have to work backwards on a couple of them where it's in exponential form and ask for simplest form. Again, not going to be that hard. Alright guys, I hope this video helps. You are going to start working on your homework. I think it's like 5 or 6 problems. My students, Mr. Nolan's students, if you finish your homework early, bring it up to me. I'll grade your homework. You'll be done for the evening. That way you can enjoy your evening. Alright guys, have a great evening. Talk to you later. Bye.